Hey guys, all right, so this is our Unit 2 review number 1. Oops, can't see there. All right, so let's just go for it. Okay, so number 1, it says given f of x equals x squared and g of x equals the square root of x, Milo carried out the following calculations. G of x equals, f of g of x equals the square root of x squared, oh my gosh, can't even speak, is equal to x. And we need to see what his error is. It says, based on his calculations, Milo states that the functions are inverses of each other. So we have to go back to the definition of an inverse. It says, what is the error in his reasoning? So he has made a mistake in his reasoning. But if you remember, right at the beginning of this unit, this is when we talked about all that stuff. So what we talked about was that if two functions are inverses, that means when we find f of g of x, it should equal x. And here's the big piece, g of f of x should also equal x, forwards and backwards. So that just means that Milo messed up. He only gave half of the statement. He needed the other half. He needed to state also that f of g of x is also going to equal x. And then that's how we know that they're inverses of each other. So the answer is A, g of f of x must also be equal to x. Remember, y equals x is that diagonal line that goes to the graph. And remember, that's why we're allowed to Freaky Friday. We get to switch the x and the y because x is equal to y, right? Because we're looking at the line y equals x. That's the line of reflection. All right, so for number 2, it says for what domain of f of x equals x minus 2 quantity squared is its inverse, f inverse of x, equal to the square root of x plus 2, a function. Okay, so we need to figure out what domain do we need to put in place on this function so that it is a function. It's going to be a relation. We need to make sure that it is a function. And notice that usually when we Freaky Friday a quadratic, an x squared, we're going to have to take a square root on both sides. And there should be a plus or minus in front of that radical. But do you see a plus or minus? No, we do not, Mrs. Garcia. So that means that there's no plus or minus. That means this is the positive side, the top half of the sideways parabola. So that means we need to get rid of the negative side of this upward facing parabola. So you have to remember what this means in terms of the parent function. So x minus 2 quantity squared. Well, where was the parent function shifted? Well, x minus 2 in parentheses there means we went to the right 2 units. So if we go to the right 2 units, that means now the parabola is sitting on the x-axis at an x value of 2, 0. Okay, well, we want to get rid of half of that parabola because we know a parabola doesn't pass the horizontal line test. So when we find its inverse, which will be a parabola on the side, it's not going to be a function because it won't pass the vertical line test. So that's why we have to restrict the domain. So when we restrict this domain, we just want to take off like half of that parabola, just like you did in your take-home quiz a few days ago. And so everything's in terms of that x value. Now, we've been using interval notation for the most part. This one's having us use inequalities, obviously, because that's what we have to choose from there. So let's write the domain as interval, as an interval. Let's do that first, and then we'll change it to inequality. So we know we're not using anything below a 2 because we're taking it off. So it's going from a 2 all the way to infinity. So x, these are x's that are greater than or equal to 2. So greater than or equal to 2. And there's our answer. That's what the domain needs to be. Okay. And when you do a problem like this on your test, I'm expecting to see little tiny pictures that show the understanding of that restricted domain. That would be the work that you would have to show. Okay. Number 3, it says the graph of the function f of x is shown in the coordinate plane. Okay, there's f of x, a pretty parabola. It says which statements describe the graph of f inverse of x. So this is f of x. They want to know based on this, which of these are true about f inverse. Anytime it says select all that apply, more than one option is going to be correct. So what I would do is, because we're trying to find information about the inverse of this graph, let's take some points here since we have this exact graph, and let's just find some exact points. Like there's a vertex, crossing through the y-axis there. Here's another point here. That one's not quite crossing through an exact point, so let's see. It looks like the next exact points are right here and right here, okay? Because we know that we would Freaky Friday those points, right? So this one is 1, -3. The Freaky Friday of 1, -3 is -3, 1. The Freaky Friday of 0, -2 is -2, 0. The Freaky Friday of 2, -2 is -2, 2. The Freaky Friday of -2, 6 is 6, -2. The Freaky Friday of 4, 6 is 6, 4. So we can see there is our sideways parabola. This is what the inverse would look like. Okay, so now we can select all the statements that apply. So it says the graph of f inverse and the graph of f of x are symmetric about y equals x. Yes, all inverses reflect across that line y equals x. That is the diagonal line that goes through the origin. Yes, these are reflecting through that line. So yes, absolutely. That is true for all inverses. If they're inverses, they will reflect across that line. So that's true. So let's highlight that one. So I'm going to select my answers by highlighting them because, you know, it's what I like to do. Okay. And then it says graph of f inverse has a maximum point at 1, -3. F inverse doesn't have a max or a min because remember these arrows, even though they're going out to the side, they're slowly climbing, slowly climbing, slowly climbing. So it's going to go to infinity, going up and going down. So there is no such thing as a maximum on that one. Okay, so that's not it. The graph of f inverse contains the point 6, 4. There it is right there. Yes, it does. That's true. So we can highlight that one. The graph of f inverse shows a function. Well, is f inverse going to pass the vertical line test right now? No. So this is not a function. It's definitely not a function. The graph of f inverse is symmetric about the line x equals 1. That doesn't even make any sense. If they're inverses, they're going to be symmetric around y equals x. The graph of f inverse has an x-intercept at -2. Is it crossing the x at -2? Yep, sure is. That one is true. So there were 3 correct answer options. The first one, the third one, and the last one. All right, so that's all on the first page. Oh man, it didn't print front to back. What a waste of paper. All right, so it says in number 4, a square root function is shown in the coordinate plane. So it says, what are the domain and the range of the function? So remember, everything goes off of that critical point right there. And that critical point is at -5, 2. So everything's going to be based off of this x value and this y value. And remember, the arrow goes to infinity. Okay, but an end point, this is where it stops. Okay, that's why that's a critical point. So when we take a look at this for the domain, let's just go ahead and list it. We'll use interval notation because that's what we're used to. And so let's see, the x value that's being used here is a -5. It's never going below -5. So that means I'm using -5 to infinity. The y value being used here is a 2. It never goes above the 2. It's only 2 and below. So that would be -infinity to 2, because you always have to go smallest to biggest from left to right. Okay, so in inequality notation then, this means that x's have to be, because it's going to positive infinity, greater than or equal to -5. So less than or equal to 2, nope. Less than or equal to -5, nope. Greater than or equal to 2, nope. Greater than or equal to -5, that one's going to be it. And then this one means because we're going to negative infinity, that means it's going from 2 down below the 2. So y is less than or equal to 2. So D is the correct answer there. Now for a problem like this, there really is not hardly any work to show. So this is a know it or you don't type situation. Okay. All right, number 5, it says, what's the solution to the equation? We had a CFA on this. That was CFA number 4. Remember, if you still have CFAs to do, you need to come in and get them done ASAP. All right, so let's solve for x. So we need to get the radical isolated. So we need to add 3 to both sides. We got the square root of x minus 4 is equal to 5. We need to take the square root off, so that means we need to square both sides. So poof, the x minus 4 gets to come out. 5 squared is 25. And then we need to solve for x. So we need to get rid of that negative 4, so plus 4 plus 4. So x is equal to 29. But we got to check it. Now, here, there is no option that says no solution. So this is the solution, x equals 29. But on your CFA, you do get a point for checking it. So let's just go through it, make sure that we check it. Whenever you check it, you always plug it back into the original. So we're going to plug in a 29 for the x. So square root of 29 minus 4 minus 3, is that going to equal 2? Well, 29 minus 4 is 25. The square root of 25 is 5. And 5 minus 3 does equal 2. So you checked it. It works. That's our answer. Number 6, it says Mario solved the equation x equals square root of 16x plus 1 plus 10. Using the steps below, he said that the solutions are x equals 3 and x equals 33. And then it says at the bottom down here, what was Mario's first mistake? He made a mistake? Oh, so we're trying to find his mistake. Okay, so here's the original problem. It's written down correctly. You need to isolate the radical, so he would need to subtract 10 on both sides, which it looks like he did, x minus 10. And then we could take the radical off by squaring both sides, which is what he did. So, well, it shows it in this next step. And then we just need to check this here. So whenever we square a square root, the stuff inside comes out. Over here, you have to remember that x minus 10 squared means you have to multiply x minus 10 times x minus 10. And then distribute. X times x is x squared. X times negative 10 is a negative 10x. Negative 10 times x is another negative 10x. So negative 10x and negative 10x does add up to negative 20x. And negative 10 times negative 10 is positive 100. Okay, so he did that good. So then anytime you have a quadratic, you need to get everything on one side and equals 0 on the other. So he had to have subtracted that x from both sides and subtracted that 1 from both sides. So let's see, x squared minus, let's see, those are both negatives. So you add them and keep the negative. That would be a negative 36x. 100 minus 1 is 99. And then you have to factor to solve. The product is 99. The sum is negative 36. Negative 3 times negative 33 is 99. Negative 3 minus 33 is negative 36. So those are good factors. And then you break them apart and set them each equal to 0 and you solve. Okay, so these are the correct solutions. But what is he missing? Well, he did not check them. Remember, anytime you solve a square root equation, you have to check them. See, he made the same mistake that a lot of you guys still make. So when we check them, you plug them back into the original. So we're going to replace the x with a 3. So 3 equals the square root of 16 times 3 plus 1. That's all under the radical. Then plus 10. We need to see if that's true. So let's see. 16 times 3 plus 1. 16 times 3 is 48 plus 1 is 49. And we know 49 is a perfect square. The square root of 49 is 7, but 7 plus 10 does not equal 3. So that one is extraneous. So now let's check the 33. So 33, is that going to equal the square root of 16 times 33 plus 1 plus 10? Okay, well, 16 times 33 is 528 plus 1, which is 529. Let's see if that's a perfect square. So let's take the square root of 529 and see what happens. And oops, I hit it twice. And it's 23. So it is a perfect square. And 23 plus 10 is 33. Oops, 23 plus 10. So this one checks out. So x equals 33 is indeed the actual solution. So let's figure out, where was his first mistake? Well, remember, his only mistake, he did the whole problem correctly. He just didn't check it. So he did that okay, he did that okay, he did that okay. He did not check whether the solutions are extraneous. That is what he forgot. which is a common mistake. So be aware of it so that you don't make the same mistake that Mario did. All right, on to number 7. Okay, so it says, and this one's a big one, so let me zoom out a little bit if it lets me. Okay, so it says, which is the graph of the inverse of f of x equals the square root of x plus 3? So we're looking for the inverse of this. So this is a square root function, and we need to Freaky Friday it. So y equals the square root of x plus 3. Let's Freaky Friday. So when we Freaky Friday, the first step we changed the f of x to a y. Second step, we have to switch the x and the y, Freaky Friday. And then we need to solve for y. So we need to get that radical off, so we're going to need to square both sides. So we'll get x squared is equal to, poof, y plus 3. And then we need to subtract 3 from both sides. So then the inverse is y equals x squared minus 3. And we could put the function notation back on it, but we don't really need it. We just need to see what's the graph of the inverse. Well, it's an x squared, so it's a parabola, and it looks like a shift of the parent function. Minus 3 on the end there means it's going down 3 from the parent. But because this is only a square root function and there's no plus or minus, this is a positive square root. This is only going to be the top half of the sideways parabola, which means this is going to be only the positive side of the upward facing parabola. So we know it can't be A or B because that's a top half, that's a bottom half of a square root function. It's got to be C because it's facing up and it's only been shifted down 3 from the parent function, and it has. So C is it. Okay, so your work to show on something like this is just Freaky Fridaying the equation, the function, so that you can find the inverse, so that you can know where the graph is. All right, number 8, it says, which of the following functions is 1 to 1? So 1 to 1, remember that means that it passes both the vertical and the horizontal line test. And so all of these are cubic or cube root functions. And we learned that if it's a shift of the parent function, all parent cubic and cube root functions are 1 to 1, as long as they're a shifting of the parent function. When there's extra junk in the trunk, that's when it's not going to be 1 to 1, because then it's going to create those extra humps. So let's investigate each of these. F of x equals x cubed plus 1. We could tell that that is being shifted up 1. That is a shifting of the parent function. That one is 1 to 1. Check. Is this a cubed root of x minus 2? The x minus 2 underneath that radical means it's shifted to the right 2. That is a shifting of the parent function. That is 1 to 1. Check. This one, though, x cubed minus x, that one is not a shifting of the parent function. I can't even rewrite that so that it would be. So this is extra junk. So that one is not 1 to 1. Okay. Same with this one. You see how there's an x squared in there? We don't usually have anything other than an x under a radical. So again, we've got some extra junk in the trunk. That one's not going to be 1 to 1. It's going to make the cubed root function. It'll still look like a cube root. Like a normal cubed root, it's the squished s, right? So that extra junk in the trunk is just going to make little extra waves in between so that it's not going to pass the horizontal line test. So that one's not going to be 1 to 1. But f of x over here, x minus 2 cubed plus 3, we can see that's a shift to the right 2 and up 3. It's a shift of the parent function, so it's 1 to 1. And then this one is to the left 1 and down 2, another shift of the parent function, so that one is 1 to 1. All right, and so I would highlight each of these. I mean, that's what I prefer, but if you don't have a highlighter nearby or handy, then just make sure that you clearly mark which ones you think are the answer. Okay. All right, because your test is going to be a combo of multiple choice and a combo of select all that apply. You still got to show your work on everything, though, because no work means no credit. So got to make sure to do that. All right, number 9, it says, what is the inverse of f of x equals x minus 2 cubed plus 7? So there are 2 ways you could do this. Way 1, way 2. Way 1 is going to be the easiest way. If you remember that cubic and cube roots, shifting of the parent function, have a shortcut, then you can take the shortcut. So let's use the shortcut. This is a cubic. So that means the inverse, f inverse of x, is going to be a cube root because they got to be inverse opposites, right? We can Freaky Friday the horizontal and vertical shift. Going to the right 2 and up 7, those are both positive moves. Going to the right is positive, going up is positive. So when we switch them, we have to switch them for equally same positive moves. It's just now the 2 and the 7 are switching. So x minus 7 goes underneath that radical, and plus 2 goes outside the radical. So we know that the answer is C. But let's just say you're in the test and you're like, I don't trust myself. I kind of don't remember the shortcut and I don't want to goof. Or you want to double check that you did the shortcut correctly. Freaky Friday it. So y equals x minus 2 quantity cubed plus 7. Then we Freaky Friday, switch the x and the y, and start solving for y. So the first thing we have to do before we can get y out of that cube is we got to get it isolated. So subtract 7, and then we'll get x minus 7 equals y minus 2 cubed. And now we can undo the cube by cube rooting, which is where the cube root comes from. So poof, the y minus 2 comes out, and on the left, we're just going to have the cube root of x minus 7. But then we have to add that 2. Now remember, you can't add negative 7 and 2, because negative 7 is an inside number. 2 is an outside number. So f inverse of x is just going to equal the cube root of x minus 7 plus 2. There it is. Okay, so those are your 2 ways. If you can see the shortcut way, then this is the only time I'm okay with you not showing any work. But if you select the wrong answer and you didn't show any work, I can't even give you partial credit. So it helps when you put down something, okay? Sorry, I got a tickle in my throat. I had to drink something. All right, number 10 says, what are the restrictions on x in the rational expression? That means all we have to look at is the denominator. Well, in the denominator, x squared minus 4 would factor down to x plus 2, x minus 2, which means the restrictions are x can't equal negative 2, and x can't equal positive 2. So C. Oops, I forgot to highlight that one. Number 11 says, what is the simplified form of this rational expression? So we're dividing fractions, and they're easy as pie. We're going to have to flip the second and multiply, but first, we need to factor everything. So, now if you look at the answer options, none of those answer options have restrictions. So, that means we don't need to worry about restrictions for this problem. So, let's see. X squared minus 5x plus 6. Let's see, that's going to, 2 numbers that multiply to 6 and add up to negative 5. That's going to be negative 3 and negative 2. Negative 3 times negative 2 is 6. Negative 3 minus 2 is negative 5. Bada bing, bada boom. X squared minus 1, that's a difference of squares. X plus 1, x minus 1. X squared minus 2x minus 3. Let's see, 2 numbers that multiply to negative 3 add up to negative 2. So minus 3 plus 1. And then 2 numbers that multiply to 2 but add up to negative 3. That's got to be a minus 2 minus 1. All right. So now we need to flip the second and multiply. We got to flip that second fraction. So we're going to have x minus 3, x minus 2, all over x plus 1, x minus 1 times x minus 2, x minus 1, all over x minus 3, x plus 1. And here we go. Let's get some cancel happy going. So let's see. X minus 3's will cancel. X minus 1's cancel. And then that's it. So all we have left is x minus 2 times x minus 2 all over x plus 1 times x plus 1. But if you look at the answer options there over to the left, they are not in factored form. They are in standard form. So we're going to need to multiply these out again. So we had to factor them so that we can cancel out factors to reduce the fraction, but then we have to multiply them back because the answer is in standard form. So here we go. These are perfect square trinomials because we're multiplying 2 of the same factors together. So I'm going to skip some steps. I'm going to do some adding in my head. So pay attention. Lock in right here, guys. So x times x is x squared. x times negative 2 is a negative 2x. I'm going to hold negative 2x in my brain. Negative 2 times x is another negative 2x. Negative 2x minus 2x is a negative 4x. And then negative 2 times negative 2 is positive 4. And then for this one, x times x is x squared. X times 1 is an x. I'm going to hold that x in my brain. 1 times x is another x. X plus x is a 2x. 1 times 1 is 1. So this is the answer. X squared minus 4x plus 4. That one has it. X squared 2x plus 1. B is it. So B is the answer. Okay. Number 12 says, what is the simplified form of this? We're subtracting fractions, so we're going to need to get a common denominator. Okay. Well, these denominators are definitely not in common right now. We need to make them be in common. So that means we're going to need to see what they're missing. This x minus 4, let's see, it needs to have an x minus 6 like the other fraction does. So I'm going to multiply top and bottom by x minus 6. This one needs an x minus 4. So I'm going to multiply top and bottom by x minus 4. And then here we go. Let's do this. We've got the common denominator now. It's got an x minus 4 and an x minus 6, or vice versa. It doesn't matter the order you put these two in. When we multiply by 1, that doesn't change the x minus 6 at all. So just bring it down. You can take the parentheses off. Now this x, because we're subtracting, is not just an x. It's a negative x that we have to distribute. So negative x times x is a negative x squared. Negative x times negative 4 is a positive 4x. Okay, and now we need to combine like terms and write this in standard form. So let's see, that's going to be a negative x squared. 1x and 4x is a 5x. And then there's that minus 6. All right, all over x minus 4, x minus 6. Okay. The only other thing I would check is to see if anything cancels. But if you look at the answer options, all 4 answer options have x minus 4, x minus 6, which is what we have in the denominator also. So that means nothing's going to cancel. So this is, in fact, the answer. So that means the answer is D. Number 13. Okay. So it says, Armin simplified the complex fraction and found the appropriate domain restriction as shown. So it shows all of his steps, step 1, step 2, step 3, step 4. In which step did his first error occur? Okay, so we're trying to find a mistake again. The best way to find a mistake is to actually do the whole problem out and verify steps as you go. So step number 1, he simplified the numerator, and so let's simplify the numerator. We've got a complex fraction here. So remember, these are the ones where I told you guys pretend that the bottom doesn't exist and just look at the top. So we need to put that x over 1, make it a fraction. And we need to get a common denominator. It needs an x plus 1. So I'm going to multiply top and bottom by x plus 1. So we have the common denominator. It's x plus 1. When we distribute this x times x is x squared. X times 1 is a 1x. And then the other fraction has the common denominator, so we didn't have to multiply anything to this fraction. So just put minus 2. Oh, look, it's already in order. That one's done. So we just don't have it factored yet. So let's go ahead and factor that numerator and see if we get the same thing that Armin did. So let's see, 2 numbers that multiply to negative 2 add up to 1. It would be an x plus 2 and an x minus 1. And that's exactly what he got. So his step 1 checks out. Step 1's good. So that means it's not A. He didn't make a mistake in A. Okay. Step 2 is to simplify the denominator. So let's do that now. So put that 1 over 1. It needs an x minus 1 in the denominator. So I have to multiply this one top and bottom by x minus 1. The common denominator is x minus 1. 1 times x minus 1 is just x minus 1. And then we have a plus 2. Combine like terms, negative 1 plus 2 is a 1. So that's x plus 1 over x minus 1. And that's as low as that could go. And that is exactly what he got there. So step 2 checks out, which means B is not the answer because step 2 didn't have a mistake in it. Okay, step 3. Multiply the numerator and denominator by the reciprocal of the denominator to rewrite as, okay, so this is where we take the middle fraction bar and we're dividing fractions as easy as pie. We flip the second and multiply. So let's see. So what I like to do is I like to write it out first. So horizontally. So x plus 2, x, oh, that's supposed to be a minus, x minus 1 all over x plus 1 divided by x plus 1 over x minus 1. I'm not going to flip the second to multiply yet because what are we supposed to do in this step first? You're supposed to state the restrictions. There's 2 of them, so x cannot equal plus or minus 1. Okay, you have to state the restrictions before you get cancel happy, otherwise you're going to lose what they were. All right, so now I'll continue this down here. So we have x plus 2, x minus 1 all over x plus 1, flip the second and multiply. And now we do have something new in the denominator, but we already have that -1 listed, so we don't need to list it again. So that part's done. Now we can get cancel happy. Oh, actually, before we finish, let's make sure we have that. X plus 2, x minus 1, x minus 1, x plus 2, x minus 1 squared. Yeah, that's what 2 of them mean. All over x plus 1 squared, that's what 2 of them mean. So step 3 is good. So that means the answer has got to be step 4. So what did he do? Let's see. Does anything cancel? No, nothing cancels. So all that's left is an x plus 2 and an x minus 1 squared because there's 2 of them, all over an x plus 1 squared because there's 2 of them. And let's see what he wrote in step 4. Write the simplified answer. Yeah, that's exactly what we just wrote. Oh, he only put that the restriction is x cannot only equal -1, but it's plus or minus 1. So there is the mistake. He forgot the other restriction, which is why I have you guys list restrictions before you flip the second and multiply, because that is a very common mistake that does happen. All right, so D was the answer. Okay. All right, number 14, a charter boat charges $40 for a group reservation and an additional $15 fee per person in the group. Which of the following functions represents the amount by which the cost per person changes when the number of people in the group N increases by 1? Okay, so let's see. Let's start with what they're charging. So the charter boat charges $40 for a group reservation. That's a flat fee. And an additional, so that means a plus sign, $15 fee per person in the group. And it looks like N is representing the number of people in the group. So 15 per person, so 15N. Okay. So remember, this is the cost. This is a total cost. But we want to split the cost between all the people that are going in this group. So we have to divide that by N. We're writing a rational function, kind of like the fee per camper situation. But then it says, which of the following represents the amount by which the cost per person changes? So there's going to be a change in cost when the number of people in the group increases by 1. All right, well, if we're increasing by 1, we're adding 1 more person. So it's still going to be a flat fee of $40 for the group plus $15 per person, but now we added in a person, so N plus 1, which means we also have to take that into account. We have an extra person to divide the cost between. Well, if you have more people that you're dividing the cost between, that means this cost is going to be lower than this cost. So when we're trying to find the change in cost, we're subtracting to find the difference. That's going to be the change. Okay, so then we kind of know then it's not A and it's not going to be B because we have 2 things being subtracted. It's got to be C or D. So it looks like we got to distribute that 15. So we have 40 plus 15N over N minus, let's see, 40 plus 15 times N is 15N, 15 times 1 is 15, all over N plus 1. Got to combine like terms. 40 and 15 is 55, so it's 55 plus 15N, which means that it is C. And on to number 15. All right, abracadabra, designs and sells shirts. The average cost per shirt in an order of X shirts is A of X equals 16 plus 6X all over X. Graph the average cost function for A of X for X equals 1, 2, 3, and 4. So what we need to do is we need to make a table of values. So let's see, I'll do it over here. X and Y. Remember, Y is the same as A of X, it's always the same as its function notation. And they want us to use X values 1, 2, 3, and 4. So we just have to plug each of these in. So if I plug in a 1, 6 times 1 is 6. 16 plus 6 is 22. 22 divided by 1 is 22. So the point 1 and then 22. Number 2, when we plug in a 2, let's see, 6 times 2 is 12. 16 plus 12 is 28. 28 divided by 2 is 14. So 2, 14. Plug in a 3. 6 times 3 is 18. 18 plus 16 is 34. 34 divided by 3. I don't think that goes in evenly. 34 divided by 3 is 11.3 approximately. Okay, 3's repeat. So 3 and 11.3 approximately right about here. And then when we plug in a 4, 6 times 4 is 24. 24 plus 16, that would be 34. 40 divided by 4 is 10. So 4, 10. So we could see this decreasing curve situation here. And it's multiple choice. There are 4 graphs to choose from, so pick the one that matches your graph. Letter A. Bada bing, bada boom. There it is. All right, number 16. What is the equation of the horizontal asymptote, the HA of the graph of f of x? This is where we look at big top, big bottom, or same. So if you look at the degrees top and bottom, they are the same degree top and bottom. We have an x to the first and an x to the first, so then we have to take the ratio of the leading coefficients. Well, the leading coefficient in the top is a 2. The leading coefficient in the bottom is a 1. 2 divided by 1 is 2. So y equals 2 is the horizontal. But look at letter A. Letter A is what we call a distractor answer because it's wrong. It's not x equals 2. X equals is a vertical line. Y equals is a horizontal line. You do need to know the difference. Okay, you won't get any points if you pick the wrong one. Okay. All right, number 17. Which of the following rational functions has a vertical asymptote at x equals -4? So we've got a VA. So that means that x can't be equal to -4 because that means it occurs in the denominator. So if you were to unsolve that and move that -4 back over, you'd have to add it. That means there should be a factor of x plus 4 in the denominator. So pick the one that has an x plus 4 in the denominator. There's only one. It's letter D. Number 18 says the average cost to produce a certain device can be represented by the function a of x equals 5,000 plus 25x over x. So another average cost function. This has been the third question that deals with average cost. You can bet that there will be questions on your test about this. What is the behavior of the graph of a of x as x increases? Complete the sentence about the graph of the function a of x by entering your answers in the blanks. So you got to fill in the blanks with the correct, appropriate things. So it says the average cost per device approaches but never reaches. So the average cost per device, remember that is talking about the horizontal asymptote, okay? And it even says that. So it's going to reach this amount because there is a horizontal asymptote at, so look at the function. Is it big top, big bottom, or same? Well, if you look, we have a degree 1 in the top, degree 1 in the bottom. The degrees are the same. So that means the HA is at y equals the leading coefficient of the top over the leading coefficient of the bottom. But you got to be careful. The numerator is not in standard form. 25x should go first and then plus 5,000. So the leading coefficient of the top ends up being a 25. The leading coefficient of the bottom ends up being a 1. 25 divided by 1 is 25. So the average cost per device approaches but never reaches $25 because there is a horizontal asymptote at y equals 25. And you got to make sure that you write that exactly so. You give the cost that it's approaching but never reaches, and you have to put y equals that number. If you don't put y equals that number, it is wrong, and you will. I remember this type of question on the test. You will have a question like that on the test. Like all of these. You're going to have a question like all of these on the test. But I remember that one. Okay. And that's easy money if you remember these concepts. All right, number 19, it says, Adrian says the function f of x equals 2x minus 2 over x squared plus 2x minus 3 has a VA at x equals 1 because the function is undefined when x equals 1. Why is he incorrect? Another error analysis problem. Okay, so he says that there's a VA at x equals 1, but he is incorrect. So that means we're going to need to factor this thing and see, well, what is it? So let's go ahead and put the work up here. So we have f of x equals, when we factor the numerator, there's a GCF of 2 in common. When you divide out the 2, you're left with x minus 1. In the denominator, that's an easy trinomial. That factors down to 2 binomial factors. Let's see, 2 numbers that multiply to negative 3. Adding up to positive 2, so that would be a plus 3 minus 1. It's not a VA. What happens to the x minus 1s? Cancel. So that is a whole. So we have a whole at x equals 1, not a VA. It's a restriction, but it's not a VA. It's a whole. Okay, so there it is. So let's see what else we can do to figure out the answer. So let's look at each one. The function simplifies to f of x equals 2 over x plus 3. 2 over x plus 3, yeah, that's true. So the function is only undefined at x equals negative 3? No, it's undefined at x equals 1. It's just not a VA. It's a whole. So A is not it. The ratio of the leading coefficients is 2 over 1 equals 2. So there is a vertical asymptote at x equals 2. Hold the floor here. Anytime you're finding a ratio of a leading coefficient, that means you're looking at the same degree, top and bottom, which is talking about a horizontal asymptote, not a vertical asymptote. So you're mixing definitions there, so it's not B. The function has a whole, not an asymptote at x equals 1, because x minus 1 is a common factor of the numerator and the denominator. Ding, 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 ding. That is our correct answer. That is exactly what happened there. So then I don't even need to look at D because I see it's comparing degrees anyway, and that's horizontal asymptote. And that's number 19. Which of the following equations represents vertical asymptotes of f of x? Okay, so the VAs are whatever doesn't cancel. It's whatever's left in the denominator. So let's zoom in here. So let's see, anything in common, top and bottom. Yeah, these x minus 2s are in common. We know that that's a whole. But it's asking for VAs, so I don't care about the whole right now. That's the only thing that cancels. So that means that there are 2 VAs down there, x equals 0 and x equals negative 1. Those are our VAs. So it does say select all that apply, so we just have to select those 2, 0 and negative 1. Bada bing, bada boom. Okay, so now we're on to number 21. Number 21 says solve the rational equation, and what is the extraneous solution? So this one doesn't want the actual solution. It wants the one that doesn't work, the extraneous solution. Okay, so it's going to help if we write this because that's just way too small. So 1 over x minus 3x over x plus 3 equals x minus 24 over x times x plus 3. Okay, here we go. So when we learn to solve these equations algebraically, what we got to do is eliminate the denominators. Got to get rid of them. So we have to multiply by whatever it takes to eliminate the denominator. So we need to get rid of an x. So I'm going to need to multiply this by x. But if I multiply this by x, I got to multiply them all by x. Okay. I also need to get rid of an x plus 3. But in order to get rid of this x plus 3, I not only multiply here, but I got to multiply it to all of them. And that's going to take care of everything. So when I do that, these x's will cancel. So all I will have left is 1 times x plus 3, which is just x plus 3. You could take the parentheses off. Over here, the x plus 3's cancel, so all we have left is a negative 3x times x, which is a negative 3x squared. And then everything cancels over here, so then I could take those parentheses off, x minus 24. All right, anytime we get a quadratic, we need to get everything over on one side and equal 0 on the other. But I do notice something that's about to happen here. If I subtract x from both sides, look what happens. They turn into 0. So then all I have left is negative 3x squared. Oh, don't forget that 3 in front is equal to negative 24. All right, so then because there's no middle term, we can just get everything over on one side. So let's go ahead and subtract the 3. And we'll get negative 3x squared is equal to negative 27. When they're both negative, you add them and keep the negative. We need to divide both sides by negative 3. A negative divided by a negative is a positive, so that would be x squared is equal to 9. And then how do we undo something that's squared? We square root it. But remember, whenever we solve and take a square root, there are two solutions. X equals positive 3 and x equals negative 3, the plus or minus. Okay, we have to figure out which one of these is extraneous. So to find an extraneous solution in one of these problems, we have to look at the restrictions. There are 2 restrictions here. X cannot equal 0 and x cannot equal negative 3. Oh, there it is. X cannot equal negative 3, so this one is the extraneous solution. So this one is the correct solution, but they didn't want the correct solution. They wanted the extraneous solution. So this is the droid that they were looking for. So x equals negative 3, B is the correct answer. And this one is the last one, the last of the Mohicans. All right, number 22. We just talked about these. So here is our rational graph, and we're talking about an inequality. So it says the function f of x is graphed on the xy plane. What is the solution to the inequality when it is greater than 0? So greater than 0. So it does not have the or equal to bar, so it strictly has to be greater than. Greater than means above. So above the x-axis. So it helps if you have a highlighter to represent this. So here's the x-axis. So the only part that is above the x-axis is this sliver right here. Okay. We need to figure out the x values that it is between. It is between these x values. So it says that that is the coordinate 2 1/3, 0. So the x value here on that point is 2 1/3. And then the x value right here at this wall is a positive 2. Okay, so that means this is an in-between statement. X is in between two things, and it can't equal either of these things because it can't be on the axis, and we can't equal an asymptote anyway. So the bigger number is the 2 1/3 because it's to the right. The smaller number is a 2 because 2 is smaller than 2 1/3. So x is between 2 and 2 1/3. So the answer is C. And there really isn't much else to do with that. Okay, you got to know your inequality symbols. All right, that's it, you guys. Have a good one.